Okay, so here we have the spreadsheet that I've created. I've got multiple columns, the HC Maker 7, the TiVo Black Widow, Tronxy X5S. I've also put a couple of generics in for a Ramps 1.4 board and space for the MKS S-Base 1.3. Even though I'm not using these in a printer yet, I figured I might as well start putting in some parameters for it. So what I did down the side here is I've put in the board type that you'd have to tell Marlin that you have so that it will program it and use it correctly. It links to the pins configuration. So the HC Maker 7 is an Ultimaker compatible board. TiVo Black Widow, as I said, is a Ramps 1.4 EFB, which is extruder, fan, and bed for the outputs. The Tronxy X5S is a Melzi board, and it uses a lower end processor, the 1284 at 16 megahertz instead of the 2560 at 16 megahertz. The other two, Ramps 1.4s are based on the 2560 controller processor. And the MKS base is based on an LPC 1768 microcontroller. Anyway, we're not going to talk about that one right now. By default, the HC Maker 7 came with 1.0.3 Dev edition of Marlin. I haven't upgraded that yet, but I do need to upgrade it. The TiVo Black Widow came with 1.1, and that's what it's currently sitting with. The Tronxy X5S, I think, also came with 1.1 installed, and I've upgraded it already to 1.1.8, but I may not have all of the safety features turned on. The other ones are all 1.1.8 because that's just going to be their defaults. 8-bit microcontrollers for all of these except for the last one. They're all running at 16 megahertz. Flash, they've got USB connectivity. All of these boards are going to use the Mega 2560. I haven't put that in there yet. Put that there and pop it in there. The default drivers that came with these boards, the HC Maker had the A4988 in, which is probably why it does not suffer the salmon skin artifacts. There are some artifacts, but it's not the salmon skin / tree ring effect. The TiVo Black Widow suffers quite badly from it, and you can see here it's using the Texas Instruments DRV8825 in 32-bit step mode. The Tronxy X5S uses an A4988 controller, and the generic Ramps board that I have at the moment has got some DRV8825s as well for it, though I will probably, I think, use the A4988s or Trinamics when I implement this one. When you're using the steps per microstep, this is how many pulses that'll come from the controller to make the stepper motor that you have installed do one complete full step. So your stepper motors are typically either 200 steps or 400 if you've got a 0.9 degree stepper motor. Most printers use the 1.8 degree stepper motors, and so that would be 16 pulses to get 1/200th of a revolution. And in the case of the DRV8825s, even though they can run in 16 step, people typically will bump them up to 32-bit step to try and get a little smoother operation. It doesn't increase the accuracy over the 16, but it technically will give you a bit of a smoother ride. The typical stepper steps I've drawn in here for all of them as being 200 by default. Now, based on these previous adjustments, the stepper steps per revolution is down here. This helps you calculate what you're going to tell Marlin as far as your steps per millimeter configuration is going to be. So aside from the one using the 8825 controller, which has 6,400 steps per revolution, all the rest that are using the A4988s are using 3,200 steps per revolution. Now later on, when we start doing the upgrades to the Trinamics, you'll see that this actually won't change, even though the Trinamics may be using 256 steps, microsteps, because it's extrapolating. It actually externally is only exposing 16 microsteps per major step, but internally it's using a 256 step lookup table to very smoothly drive that stepper motor around to its next position. Typically, most 3D printers are using a GT2 belt, so I put in here a standard belt pitch of 2 millimeters for all of them for now. The XY gear teeth, so whether that's a Core XY in the case of the Tronxy X5S or these other ones, they seem to be always using 20 teeth on the gear that's directly coupled to the stepper motor. The Z-Rod, it does vary. The Tevo Black Widow has a 2 millimeter single start rod, whereas the HC Maker has an 8 millimeter, so it's a 4-start thread with a 2 millimeter pitch, which ends up giving you a millimeters per revolution of 8 millimeters. And all the other ones, I've got the Tronxy X5S also uses the 4-start 8 millimeter rods, which gives you 8 millimeters per revolution, which has but it actually has a 2 millimeter pitch on the rod. But because there's 4 threads running down, it actually means that you move 8 millimeters when you rotate one rotation. Extruders, typically all the ones I have anyway have direct drive extruders, with the exception of the Tevo Black Widow that has a planetary gear with roughly 5-to-1 gear down ratio. So then once we've got that, we can start figuring out a few things that you would want to tell Marlin using an M92 or programming the defaults in with the firmware. So with the steps per millimeter, X, Y, Z, and E, it's basically using the number of microsteps to move the bed or the head 1 millimeter, and it's just it's a function of the previous parameters we just looked at. So here you can see C16, which is the steps per revolution, divided by the belt pitch times the number of teeth, i.e. the distance moved per revolution, which ends up being, in this case, 3200 divided by 40. The Z steps is dependent on the threaded rod that you're using. So you can see here that because the Black Widow has a 2 millimeter pitch, one rotation only moves it 2 millimeters, we've got a lot more resolution available in the Z direction on the Black Widow compared to all of the other ones. The only reason this one, which is the generic, I think, Ramps one, is got 800 is because we've got a 32 steps microstepping. Wherever you've got the 16, it's down at 400. And it's assuming an 8 millimeter pitch rod. So, you'd have to adjust the figures for something else. The feed rates is just what your print mechanics can handle. And even though a lot of printers, you'll see them advertise that they can do, 800 millimeters a second and stuff like that. Really, even though they technically could do that, you'd get some really crappy prints if you tried to run it at that speed. And the quality of your print is dependent on how fast you can move and stop the head without causing any ringing, and also how quickly your hot end is able to heat the filament to keep up with the extrusion rate, because the faster you move, the faster you've got to push that filament through the hot end, get it from room temperature to 180, 200, 250 degrees and out onto the print bed. So the faster you go, there's a lot more work you've got to do. And typically with a 12-volt system, you're not going to be able to achieve those high rates. Even though mechanically the printer may be able to do it, your quality is going to suffer crazily. Acceleration parameters, you can see here, these ones were read from the 3 printers that I have. These ones I've just left at the defaults. And this just says how quickly from a standing still or from one speed to another speed can you accelerate, and it's millimeters per second per second. Usually these values are fairly high. We then have things like acceleration when we're printing. These are the maximum accelerations, so you cannot go above that. But then this is subdivided into acceleration for printing, acceleration for retraction, which of course only affects the extruder, acceleration for travel, so where you're going from one position to another. Coming down a little bit more for some of these other settings, these M205. On the left I put the G-code commands that would relate to those. We've got the minimum feed rate, minimum travel rate, so these are zeros. You can slow them right down. Minimum segment time, the jerk. Jerk is something that's talked about quite a lot, but not many people already have figured it out too much. You can see the figures here. They're pretty much all using the defaults as far as the firmware is concerned. Offsets. So what these offsets are something that allows you, if your X, Y, and Z microswitches, if you're using microswitches, home your head and bed off the edge of the bed, then you can apply some offsets to say where the 000 position is for when you're printing, so that you're not actually having a wasted space or running the risk of printing off the edge of the bed. The next section with the M145 is the PLA and then ABS typically default print settings. So if you when you hit the button on the display and you tell it you want to preheat PLA or preheat ABS, this is where it takes those parameters from. And you can see they're all different for the three different printers. This is the HC Maker. We've got the TiVo Black Widow and the X5S. They're all fairly close, but the one thing that I think really shows the differences in the bed temperatures. Both the HC Maker and the Tronxy can't get their temperatures up to 110, even though this one says it can. This one at least limits you to a realistic temperature that the printer can get to without modification. The TiVo Black Widow can get way above 110 if you wanted to. PID control loop settings. These are just the ones that I found that were in the existing firmware, so I've just recorded them. You can do an auto tune if you've turned them on to optimize this, and it would adjust these values, of course. Filament settings. What I found is that they were disabled. Default material diameters. Two of them had it set. One of them didn't. And often this really, it is actually controlled by Cura or Slicer because it sends the commands on how quickly to move the extruder versus the X, Y, and Z motors. So the filament diameter is more something that you tell Cura about. Okay, so you would tune that. Also, the steps per millimeter, extruder steps per millimeter is the steps required to move the filament going into the hot end by that number of millimeters. By a millimeter. So 93 steps would actually move the filament 1 millimeter into the hot end. But the hot filament coming out of the hot end obviously is going to be a lot faster because the 1 millimeter at 1.75 or 3 millimeter diameter is going to equate to a lot more once it's extruded out to a 0.4 millimeter stream coming out of a 0.4 millimeter nozzle or whatever nozzle size you've got. All right, so this setting is actually for the preheated and pre-extruded filament. Going down here, what else have we got? That's pretty much it for those settings. The next column I've got is a capture of the config.h that I found for some of these printers, and these are based on what I found on GitHub for them. And some of them are quite all over the map. Let me just go to the top here. So we've got the Marlin 1.1.8 default settings. This is taken from the GitHub and is just the configuration.h that is right there, effectively preset. So when you download Marlin to create something for a brand new printer, this is what you're going to see. So they default for a baud rate of 250,000 baud. Nothing set up for your splash screen stuff particularly. It just calls the printer a 3D printer, and as you can see, the HC Maker hasn't even changed it in their software that they sent me, although when I'm running the printer, it actually does say HC Maker on it. It doesn't say 3D printer, so I know that it's not perfect, but that's basically it. You can see here that Marlin by default still has a 3 millimeter diameter filament set. All the other ones have been adjusted to say 1.75. What I've done here is anything that's in green means it's exactly the same as the Marlin default. Where it's yellow, it's undefined, and I've put the word in undefined. And where it's blue, it means that they've changed it from the Marlin defaults. Now, things like here, which is for the HC Maker 7, when we get to the safety settings, this is one of the areas where you really don't want to have something like this set, and I will be changing this when I reprogram my HC Maker 7, because if having a minimum temperature of 5 degrees means that if your thermistor gets shorted out or made open circuit, that goes to the max temperatures as well, by the way, what I'm saying here, then it's going to read below 0 or 0 or something, or it's going to read some ridiculously high value. By having these parameters set to something that's not 0, for instance, but below what would be your normal room temperature, if there is a issue with the thermistor, it will be able to detect it. So, you know, this value of 0 is really not what you want. Okay, so dropping down here, I'm not going to go into great detail with all of these. I'm just going to kind of like highlight where there are differences. Maximum bed temperature. This is the maximum temperature that you can set the bed to. Only one of these seems to be varied away from the default of 150, which is the Tivo Black Widow, and it has it set to 125. So technically you wouldn't be able to adjust the dial on the front to go above 125. The other two are set to 150, but you know, we already know from other videos that there's no way that these are ever going to reach that kind of temperature, not with the current configuration of the hardware. Yes, I want to use PID temperature control, which is proportional, integral, and derivative control, both for the for the nozzle, but for some reason these are disabled for the heated bed. It's just bit banging basically on and off, not proportional control. It is using PWM, but you know, I think I might want to try turning this on. Few factors for the PID control. Again, these can be tuned. This one allows you, PID auto menu will allow you to enable auto tuning through the LCD display. You can send a G-code command to make it do the auto tuning, but this would make it easier from the display if you've got the memory to handle it. You can see here some of the versions don't have it defined. That doesn't mean that the firmware isn't supporting it, or at least the latest Marlin firmware is. But remember, this one here, which is the HC Maker, it's a very early version of Marlin 1.0.3, as opposed to the defaults which I'm looking at, which is for 1.1.8. So there's a lot of things that are not defined in some of these other printer settings. Some of the more important ones are things like prevent dangerous extrude, which would, you know, if your extruder is not heated up, then you really don't want to be trying to extrude plastic. Otherwise you can, at minimum, grind the filament. Worst case, you could damage something. If you do want to extrude minimum temperature, this setting allows you to define what that is, and in all cases it's set to 170. I don't think there's any filaments that are commonly available that would extrude below that temperature. A few other settings. Let's have a look. Thermal protection is here for thermal runaways, and you can see that now by default Marlin has it enabled, but in this case the HC Maker has it disabled, which, you know, I'm going to change that. End stops, this is just standard configurations, whether you've got, depending on how your end stops are wired, whether you're using pull-ups or pull-downs. You can see that most of these have variations. You just need to figure out what you're using, and if they're wrong, it's easy to change it to make it right. Default steps per unit, this is what we were looking at on the previous page, where we were calculating things like the steps per millimeter and everything else. In here you can default the hardware. Now there's nothing that stops you from tweaking this, so you don't necessarily have to change it when you burn the firmware. You can go in, as long as you've got your flash EEPROM enabled, you can tweak it through the LCD display and then just save it, or you can send an M command and save it to the E2PROM, so that you can then use those new values going forward if you ever had to tweak them a little bit. But technically you should never be adjusting things like the XYZ steps per millimeter for any of these. You can see that the default is based on assuming a 16 steps micro stepping typical, with a very high XYZ 4000 for the Z-axis. I don't think any of the ones I've seen have been anywhere close to that. So I'm not sure what they would have been using, but yeah, you definitely would need to change these either through the display once you've burned it, or through the using the calculations like I showed before and setting it in here when you burn the firmware. Max acceleration for defaults, etc. We've talked about those before. This is just going through what the settings are in Configuration.h. The Z probe, the probe is for bed leveling, and the default is to use the Z max end stop pin. This allows you to tell it that you're using the Z min. So if you want to have a micro switch, for instance, for the standard homing position, but then use a BL touch or some other sensor, maybe an inductive sensor or something, then you could actually have it running on a different pin if you wanted to. You would disable this here and it would automatically then use the Z plus pin, allow manual probing, auto probing, etc. BL touch, so all you have to do to enable a BL touch is to change this to uncomment the BL touch line, and it will automatically use the servo 0. If you actually look in configuration.h, so let me just bring one up a second, it actually tells you all of these different settings and what they are. Okay, this one I'm looking at here is pins. Let me just bring up a configuration. Here's a configuration.h. So there's a lot of comments that are in here telling you what all of these parameters do. So I haven't put all the comments into that spreadsheet because it's not relevant to do that, because it's just duplicating what's here. I've just captured a lot of the actual settings and just put them in there so you can have a side-by-side comparison. So going down here, let's have a look. So if you're using a bed probe, you need to be able to tell it what is the offset from the extruder, so that it knows that it's going to stay on the bed and things like that. Clearances, the speed that you're going to use for the Z probe. This is for the machine for inverting this direction pins for the stepper motors. So if your head is moving in the wrong direction, or your X and Y is moving in the wrong directions, you can invert this by saying true or false, depending on what it's already set to get it to go in the other direction. Homing direction, is it the bottom left, is it the front right, rear right, etc. You can adjust this to tell it where things are. The default is the front left and the head coming, the extruder head coming down to go 0, 0, 0. Bed size is often handy. In some cases, like it's not defined, but really if you set it up to the size of your bed, then you can have things like soft limits that prevent any erroneous G-code from sending the head off to the other side of your printer and crashing it into something and grinding stepper motors and stuff like that. It'll allow you to have some kind of protection there. X minimum position 0, 0, 0, so that basically prevents you from letting your steppers go past the limit switches. Z max position is typically the height available of your printer in the Z direction, of course. Filament runout sensors, if you're using one, you would enable this. By default, it's disabled. Most people don't have one. If you need end stop pull-ups enabled, there's a lot more to the end stop pull-ups, but look in the configuration.h for more details on that. It's quite well documented, but the pull-ups are always needed when you're using something like a simple micro switch. Mesh bed length. So for calibrate, this is all about auto and manual bed leveling, and whether you want to use mesh bed leveling or some other procedure. And the configuration.h has a bit more details about that. What this is doing is telling you how many X and how many Y, the nozzle size you're using, the temperature that you want to have the hot end, so because you may do some extrusion tests as well. So these are a whole bunch of parameters that are all to do with bed leveling. Now, when it's disabled, then all of this stuff, even though they may be in there, they're not being used for anything. You'd have to have the mesh bed leveling or one of the bed leveling setups enabled in order to make use of these other parameters. What I've done here is a lot of them were undefined, but even where they were defined, these ones were actually disabled because they had a little if defined bed leveling, then these would get enabled, otherwise it would be disabled. Minor point, but it's just that it was a little difference in the configuration files. Safe homing is something that allows your printer to home in X and Y before it starts moving the Z-axis. That way you're not going to bring the Z-axis down and crash it into something horrible. And if you do have the safe homing turned on, then you tell it where you want it to safe home, and all of these default parameters is actually in the middle of the bed. Now these are all showing disabled, but I do know that my TiVo Black Widow actually does go to the middle of the bed when it homes the Z-axis. So technically in the configuration as shipped to me, this was enabled, even though by default what I found on GitHub, it's got it disabled. Feed rates for homing, so you can adjust how quickly it homes and things. EEPROM settings. This one is worth turning on if you have a controller that's got enough flash to be able to have the extra software in there, because it allows you to save and override the settings. Chit Chat allows things like Repetier, Prontoface, and Octoprint to be able to communicate and get information back and show the EEPROM settings on the local screens of whatever you're plugged into the USB interface. Temperatures, we've already discussed those before. Default temperatures for PLA and ABS. Nozzle parking features. So when you finish printing, where does the nozzle go to? Things like that. Print job timer. So how long has the print been taking? How many prints have you done? This LCD is something that seems to be universally set to almost the same way, because almost all the printers have one of 3 displays on them. You either have a 4-line by 20 character LCD, you have a full graphic LCD display, black and white or whatever color it happens to be, that is typically 128 by 64 pixels, or you have one of these newer touch screens with full color display and stuff as well. I don't have any printers like that at the moment, but almost without fail they're all set to English and set to the Japanese for the character set. Don't know why they're Japanese and not something else, but that's just the way they're all set to. The displays that are being used, typically for the ones I've got, they're all using the RepRap Discount Full Graphics Smart Controller. So that's why these 3 are enabled. Now for some reason my TiVo Black Widow has also got, is that the Black Widow? Let me just go back up and check. Yeah, the Black Widow has also got a secondary display enabled for some reason, don't know why, which is the Ulti panel. I don't know what difference that makes, but it's enabled too. Extras are things like soft PWM scaling. They've all been set to 0 for all of those. When you printing from SD and you do a stop on the front panel, does it want to do an automatic cool down? These are typically enabled on one of my printers, undefined in one, and disabled on the other one. So I would suggest having that enabled so that if you do stop it, it'll let things cool down. But it depends on what you want to do. If you're going to stop it and walk away, you're going to stop it remotely, you may want to have it automatically cooling. If you're stopping it to quickly pull something off because it had a failure of some kind, you want to get it going again, maybe you don't want to have it cooling down right away. Servo delays, filament diameters. Again, we discussed this before. You really want to set this up to at least have the filament diameter put in. But I think these are mostly used when you are using a filament diameter sensor. So, and it sets the limits of how it's going to let it operate and things. None of my machines have that, and I haven't seen a printer yet that actually has that. A filament run-out sensor, yes, but not a filament thickness detection. These are the ones up here. Sorry, I think I skipped over a few. Things like the encoders typically all seem to be normally enabled. The other bit, which is what, and these are all, the meaning for all of these are consistent no matter what the board is as well. So the one thing that I did have an issue with, as I mentioned earlier in the video, was for the HC Maker 7, I didn't know what board it was. So what I had to do was, let me just bring up a picture of the board here somewhere. Where is it? There. This is a picture of the board. So here is the ATmega 2560 microcontroller. And what I did was I pulled up the Pins.configuration. All right, they're in Marlin, and if I bring up one of them, I had one here for the Ultimate. This is actually the one that that is correct. And if you look at these, there's some consistency in that you've got this hash define xmin pin, tab 22, or depending on which pin it is. So pick a pin. This 22 is the Arduino equivalent pin of the software that defines what pin you're using for this. And there's the step direction and things like that as well. And the way to figure this out, if you have a board and you don't know which one it's using, or at least what I did, was to take a multimeter on resistance mode or with buzzer mode. Go on to, say, the X stepper motor driver. Go on to, I think that one is these two are the step and direction pins. Put one end on here, and then very carefully run around the microcontroller, because there is nothing in between them. It's just traces right here, and find out what pin it is connected to. Don't press too hard, because you can bend these pins if you're not careful, or short them out or damage them in some way. So just go gentle and go around with you need something with a fine point on it, because these are very, very close together. Once you find out what pin it is, this is the physical pin of the CPU, you then need to go in and find out what pin it is for the software. So if I just zoom in on this, if we actually look at the pins for the Ultimaker, so for instance the X step pin is pin 25. So physically, so that's pin 25 up here. So let's find out where it is. There's 24, there's 25. So digital pin 25 is actually pin 75 on the chip, is digital pin 25. So if I ran around there and started probing on here, if I was on the X step, I think that's what I said I was using. Yeah, 25. Then, here's my picture here. Yeah, so if I was on X step, which would be, say, this one, and I started metering around here, I would get continuity when I hit this pin here. All right, and so then I know that, okay, my X step is connected to that pin. By using the Arduino ATmega mapping from the pin number, physical pin, which is 75 here, I know what digital pin is. I can then just simply search in the pins, right, within the Marlin GitHub. Right, I'm showing you the pin here, which says 25. But if I didn't know what that was, what I would do is in GitHub, there's all these pins further down here for all these different boards, right? Is I can actually put in the search for GitHub way at the top. I can actually search within this area for the pins string that I want. So if I was looking for, let me just go back in here again. Let's just pick that one we were actually using. So I can actually search for this. Right? I metered, so on the assumption that I metered this out, right? I don't know which file that's going to be in. There's a lot of pins files. Okay, I can go at the top, paste my parameter that I wanted to find with what I found with the mapping, and I can search, and it'll actually show me which ones have those. Now, it's, as you can see here, it's brought it up as on the different line. That's not what I want. I think I can put quotes around this, hopefully. There. Okay, so now I've got a number of matches. So I've got the old, you can see here, it's showing me the file names with that parameter with the value that I put in. So maybe I had found a different pin number then it would come up with potentially different files. But this now confirms to me that one of these files is the one that I need. And in my case, I know that this was an Ultimaker. I did a few other pins as well and kept finding Ultimaker, and so that confirmed it for me. I subsequently got the software from the folks that make the HC Maker, and they also then confirmed that it was the Ultimaker because I saw the actual configuration file they had. And that's all it took me to basically beep out the board and find out which set of pins it was using. And that allows you to program the controller with the latest version, because what you do, if I go to the very top of one of these, there's a few parameters at the very, very top which you would program in. These are all just customizable for your own use. What serial port you're using, what baud rate. Now mostly nowadays they're using 250,000. If you've got an 18 mega 2560, you can bump that up to 250,000 quite easily. Here is where you would tell it what board you've got. Now the one I'm looking at right here is for the Tronxy X5S, which is why it says the board is the Melzi. And this is the one that ends up mapping also to the pins so that it knows what pins we're using. So that's what you would then, once you confirmed what set of pins you want, you would just put that name in here, and then you could program your control system. Now this is just for the pins. Within the Arduino IDE, you've also got to tell it that you're running, you're using an AT Mega 2560, or you're using a Sanguino in the case of the Tronxy X5S, etc. But that's pretty much all there is to it. So that's what I did to figure out what all the pins were, and put them into here for everybody. Now the nice thing is that you can just do a side-by-side comparison here. All of the configuration files, even for Config.h, when if you don't know which one you're using, or you've got one but you don't know which parameters have changed, I find that a pain, that you've got to keep comparing and flipping between them and everything else, which is why I started for my printers putting these into this tabulated set of columns. If you see this and you happen to have your pins for your board, maybe it's not one of the standard ones, send me an email with the pins and the configuration thing and I'll add it to my list. Anyway, that's all I want to say for now. I think I've been going on a bit longer than I wanted to. The next videos are going to be the individual upgrades for each of the three boards I have, the Tronxy, the TiVo, and the HC Maker. Anyway, if you like this, found it useful, give me a thumbs up. If you didn't, then don't. And I'll see you shortly for the next video. Thanks. Bye.